Hello, and today we're going to be working on the physical build component of the Activity 312 Ohm's Law Lab for PLTW Principles of Engineering. So right now we're going to start by getting a 1000 ohm resistor. To do that, we want to use our key. Again, I don't know how clear this video is going to show, but we have a 4-band resistor, and it shows us the first two colors are going to be the digits, and then the third one's going to be all multipliers. So in this case, we want 1000. So the first number in 1000 is 1, so we need brown as our first band. Our second digit's going to be a 0, so that's going to be a black second band, and that gives us the number 10. And then we have to find the multiplier. The multiplier 10 times what gives us 1000 is going to be 100, so we need a red band. So we need a brown, black, red. So what that ends up looking like, I'm going to pull it up here. I'll put the white background up so maybe we can see a little better, is we end up with a brown, black, red resistor. With that resistor, we're going to plug one of the ports into one of the legs into our breadboard. What spot, it doesn't matter. In mine, I'm just going to put it in 5 because it easily fits in. And then I'm going to put my second leg in another spot on my breadboard. In this case, I'm going in 14. On your breadboard, everything's going to connect horizontally. So all the port 1, all 5 of these, A through E, all connected underneath. On the sides, we have a plus and minus. I'm going to plug my red my red lead that comes from my power supply into the red, and everything on that line connects vertically. So from the very top all the way down on both the red, the positive, and on the blue, the negative, again vertically all the way down. So I'm going to put my red into the red, and then I'm going to put my black into the negative, and then I'm just going to go in order. Actually, I'm going to do my red into the positive. Then I'm going to take a second wire. In this case, it's going to be an orange wire, and I'm going to take that from my red row. Again, it doesn't matter which one I go into, anyone on the red in the positive line. And then I have to move it into the same row as this leg in, and I have to be on the same side. I can't come over on this other side. So I'm going to go into that row 5 again. So now I've gone from my red underneath in the board, it comes over to the orange. From the orange, it goes underneath into this resistor, and now it's coming back down to row 14. From there, I'm going to use another wire. In this case, I'm going to grab a green one. It doesn't matter what color, just so we can kind of see I'm grabbing a green one. Again, I want to plug this in, follow my line, so I'm going to go in 14. And now I'm going to come back to my outside, so I'm going to come back over here on the blue. And then I'm going to bring it back to my power supply with a lead from there and put that back into negative row. So both the green wire and this black lead from the power supply into the negative, the blue vertical column. From there, that gives us a complete circuit. We have our power supply on. However, next it wants us to measure our current. So next we'll get a multimeter and show you how to do that. So we have our multimeter here, and for this activity we want to measure current. So first I'm going to change my multimeter. I'm going to rotate it around. Your multimeter could look a little different, but we want to change it over to our current setting, and we're going to be using DC current, so we want to make sure it's on DC and not AC. DC is going to be the solid line with the dashed line beneath it. Current's usually going to be represented with the symbol for amps, which is an A. And in this case, I'm just going to start at 200 amps, 200 milliamps as my setting. We could start higher. We might be able to go lower to 20 milli, but just to be safe, we're going to start at the 200 and work our way down from there. When we're in that 200 milliamp, we have to make sure we plug our probes in the right location. Our black one's already in our ground common. Our red one's already in, but I'm going to pull out. A lot of times you may be in voltage or resistance over here on the right side. We're in the milliamps. We're not doing 10 amps. If I'm doing higher current, I may be in 10 amps, but since we're at low current, we're going to be in this milliamp port. That gives us our ports for our multimeter. We'll set the multimeter up, we'll turn it on, and then in order to use the multimeter, we have to break into our circuit. So right now we have a completed circuit. However, we want to break into that circuit and have the current run through our multimeter. So to do that, my power supply is at 3 volts. As I run through it, I'm going to disconnect that orange wire that we connected earlier, and then I'm going to run my multimeter. I'm going to take my red positive lead, and I'm going to hook that up to my orange, and then I've hooked my black up to my resistor, and I'll move it so we can see a little. So hopefully now it's a little bit easier to see, but I'm taking my black and I'm just putting it on the metal leg of my resistor. I'm taking the red and putting it on this wire I disconnected that was in row 5 previously. Now it's no longer in row 5, and I'm touching that to my probe, and we can see on our multimeter we're getting readings, once I have the metal on it, of about 3 milliamps. So again, if you pay attention to your unit on your multimeter, a lot of times that's going to change depending on your setting, but we're at 3.0 milliamps, and if we check our multimeter meter over here, our power supply is 3.0 volts. So that would be the first reading we would record in our data table. Then we do the same setup. Again, our black probe is on our resistor leg at port 5. The wire we removed from that row 5 we have hooked. Now we're repeating that process at 4.5, so we're at 4.5 volts, and you can see we're at about 0.45 milliamps. We'll again move our voltage up, so now we'll move our voltage up to 6.0. Hook it up the same way, so just about 6.0. We're hooked up the same way, still the black on the leg of the resistor. The wire we removed still hooked up to our probe, and we can see we're at 0.49 milliamps. We keep going up until we get to our final value, which is going to be 0.9, so I'll keep working my way up. Next is 7.5. So I'm at 7.5. At 7.5, and we got a voltage current of about 7.75 milliamps. Finally, work our way up to 9. We're at 9 volts on our power supply, and you can see we're at 8.9 milliamps, so just about 9.0 milliamps. So that gives you your data. You plug that into your spreadsheet, and hopefully you can see a trend. For our next physical build, we're on step number 16. We need a 330 ohm resistor. So to remind us, 330, the first two digits are 3 and 3, so orange and orange. 33 times what gives us 330 is going to be 10, so we need orange brown. So we're going to get an orange brown resistor, which we have right here. So orange brown is what we want, so that's orange brown. Gold is just our tolerance. We're not going to worry too much about that today. Then we also need an LED. So we have our LED here. On the LED we have one leg's longer than the other. We're going to put that longer leg towards the positive end when we're talking about conventional flow to make sure it's oriented correctly. So we want to set these up in series on our breadboard. So I'm again going to start with my resistor. It doesn't matter the order you put it in. I'm just going to put my resistor into any port. Last time I started at 5, so I'll start at 5 again. And then I'll take it down to, in this case, I'm going to take it down to port 11. Again, which ones you put it in exactly doesn't matter as long as they're in different rows. Then I'm going to take my LED, this blue LED, and put the longer leg in the same row as my resistor. So my longer leg is going to go in 11, and then my shorter leg is going to go in, naturally, it's just going to go into the next one down, so it's going to go in 12. Then following my electricity in, I've already hooked up my positive into my breadboard. Then I have this orange wire from earlier in my positive. I'm going to take that to where my resistor is, so it's also going to go in that row 5. So I'll put that in row 5. My electricity follows through the resistor to row 11. From row 11, it goes through the LED to row 12. And then I'm going to take my black, my lead back to my negative, and I'm going to take that 12 and insert it in, and that gives us a light. I didn't change it down to 4.5 volts, so it's really bright, but here we are at 4.5 volts. So that gives us that circuit that completes our LED light. So that lit up one LED. Next we need to light up 2 LEDs. I'm going to turn off my power supply just so we're not looking in a bright light. I'm going to unplug that final green wire, and I'm going to insert another LED. I'm going to get a different color. In this case, I'm going to have a red one. Again, we want longer leg first, so we're going to have that longer leg on my LED into the blue light went from 11 to 12, so I'm going to go from 12 down to 13 with my red LED. So I'm going to plug my longer leg into 12, shorter one into 13. Then I'm going to take that green wire from before, and now instead of going into 12, now I'm going to go into row 13 and put it into that port. I'll turn our power supply on, and you can barely see. We get some dim light coming on. We got a bad connection somewhere as well, not helping the cause. But you can see our lights coming on, but they're not nearly as bright as they were last time. So we do have LEDs on, but they're not nearly as bright as last time now that we have two of them in series. So that lights up two LEDs for number 17 for us. For our next build, we're on step number 19. We need 3 100 ohm resistors. So just as a reminder for our resistors, first one's going to be 1, 0. So 1 is brown, 0 is black. So brown, black gives us 10 times 10 times what gives us 100. That's going to be 10, which is brown. So we need brown, black, brown on our resistor. I have 3 of them here. Here's what it kind of looks like if we can get it to clarify. Brown, black, brown is our color on this. And then we're going to take 3 of them and we're going to put them in series in our breadboard. So my first one, I'm just going to start near the top. So I'm going to be, in this case, I'm in port 3. And then I'm going to go down to, again, it doesn't matter which one. It looks like I'm just going to go to 10. So 3 and 10 on the first one. Next one, I'm going to start, again, this is brown, black, brown, same resistor. I'm going to start from where my last one ended, which is the 10. And I'm just going to plug in there. And then I'm just going to go somewhere farther down. In this case, I'm just naturally falling into number 18. From 18, then I'm going to go add my third one. Again, another 100, which is brown, black, brown. I'm going to start at the 100, and then I'm going to go to my final spot, which is going to be, again, it doesn't matter which one. You just need a different row than what you were in before. In my case, I'm going to end it at number 24. Then to connect it, again, I still had my power supply going in on the front end. It's still my orange wires coming from my positive or my red. I'm going to put that into port 3, same as where I started. Then at the end, going back to my negative, I have my green wire, and again, it ended at 24, so I'm going to plug that into port 24. When you turn on your power supply, you're not going to really notice or see anything because we don't have any LEDs. However, we can use our multimeter, and it wants us to measure current. So I'm going to turn that off real quick, and then hook up our multimeter. So I'll be right back. So we have our multimeter here. Again, it's set in, same as before. We got it plugged into our milliamps, our ground or common in black in its proper port, and we're set at 200 milliamps. You could also try 20, but just to be safe, we're in the 200 milliamps. I'm gonna, just like before, unplug this orange wire that was in port 3, row 3, and I'm gonna hook up my red lead from my multimeter to that, or red probe, and then I'm going to take my black probe and go to that row 3 again. And again, we're at 6 volts on our power supply, and we can see we get a value of about 19. If I can get a better hold on both of these at the same time, I'm trying to hold 3 things at once for you. So I'm going to hook that one up. We're going to put that on there, and we get a value of about 19.1. 19.0, somewhere in there for milliamps. So that's 19.0 milliamps on our multimeter for this one, and that's for number 19. So next we want to measure the resistance, actual resistance in our device, in our breadboard. So to do that, first we have to adjust our multimeter. So we have our multimeter here. I'm going to change it into our resistance setting. So I'm going to go up here, and then I'm going to go to 2K based on what we calculated. So you could start at 200, 2K. It looked like 200 is going to be too low, so we're going to start at 200K. When we're using our multimeter for resistance, we do have to move our probes. So we have to move from this milliamps over to, we want resistance, which is ohms, so we have to move it over here on this particular one on the right side. I'm going to put that down for us, hopefully in a spot where we can read it without too much glare. And then we're going to hook up our probes. We're going to put one probe on each side of our system here. So I've disconnected my power supply. I've taken that orange and green wire and removed them from our breadboard, from the leads on our breadboard. They're just in the positive and negative. And now what I'm going to do is touch one probe all the way on the far right hand side on that leg in port 3. And then I'm going to put my other probe all the way on the port 24 leg. And when I do that, I get a value of 0.296 kilo ohms. So 0.296 kilo ohms. So I'm going to try to hold this and move it so we can see it. And I pulled one out, but we got 0.296 milliohms when we did that. I'll try to get that plugged in real quick so we can see that again. 0.296 milliamps was our value. So 0.296, 0.295, and that's again kiloohms. For our final build number, I believe it's 23, or yes, 23, I believe. We're going to use a 330 ohm resistor again. So just to remind you, 3 and 3 is orange, and then to make it 330 times 10 is brown, orange, brown. So I have that resistor right here. Then we're going to use one more mystery resistor. So I'm not really going to bother showing you what the coloring is, but there's our mystery resistor. We'll plug those into our breadboards to get started. So again, I'm going to start near the top. So I'm going to start in port 5 with my 330, take it down. Again, it doesn't matter which one as long as I know where it's at, and I'm taking it down to number 12. Then I'm going to take our mystery resistor and start it at port row 12 again. And then I'm going to take it down to, again, what row, it doesn't really matter where I end it at, but in my case, I'm going to end at 20. To go back to the top then, I'm going to take my orange one that comes from the positive and stick it in row 5. And then I'm going to take my green one that comes from the negative, and I'm going to put that in that row 20 that we were in before. When you turn on the power supply, again, you're not going to see anything, and you're not going to see what it is. It tells us to set it at 3 volts, so I'm going to make sure we're at 3.0 volts. And then we want to use our multimeter to measure both our current and voltages. So I'm going to pause and get our multimeter set up. So we're going to start by measuring voltage. To do that, we've adjusted our multimeter from before we were on resistance. We moved it down to our DC voltage, and since we know it should be about 3, I'm going to put it on our 20 setting, and we're going to measure it similar to how we measured resistance, only we need our completed circuit. So our power supply on, we have a completed circuit, and I'm going to take my red probe and stick it on the leg of my first resistor here in port 5, and then I'm going to take my black probe and stick it on the leg of my second resistor, which at the end of it, which is in port 20, and it should give us a value, we're going to guess around 3. And when we do that, we get a value on our multimeter of about 3.05. So 3.05 or 3.06 in this case is going to be our voltage, so that gives us our voltage. Then we have to adjust to get current, so I'm going to change over to current. So I'm going to go to that 200 like we did before. Again, we have to move our lead to the current milliamp port. And again, we have to disconnect our circuit. We need a circuit that's not complete, an open circuit, and run the circuit through our multimeter to close or complete that circuit. So again, I'm taking that orange wire out like I did previously, and then I'm going to stick my red probe on the wire, on the end of the wire, and then I'm going to take my black probe on my resistor to give us our reading for this one, if I can get it on both at the same time. And when I do that, we end up with a value of about 5.8 milliamps. So we get about 5.7, 5.8 milliamps in this case. So that gives us our current, and the current's going to be the same all throughout. We could test at different points. You do that more in our next activity, but we get 5.7, 5.8 as milliamps as our current. That 3.05 was our voltage. From there, you should be able to figure out what the resistance is for that unknown resistors. Hopefully this helps you with activity 3.1.2 Ohm's Law Lab for Principles of Engineering POE.